Great. Thank you so much for that warm introduction, and thanks to everyone here for welcoming me to Rotary Club. I've actually spoken to a few other Rotaries, but none of this size. So it's an honor to be here, and I'm super glad for the invitation. So thank you all. So I'll be talking to you all today about air pollution and some of the work that I've done on air pollution. And before I get started, I didn't do this alone. I've had a number of collaborators along the way. So people, Amanda Murray and Alex Hughes and Corey Kirschenbaum, who have been associated with Duke University and the University of California, Berkeley, Dallin Weathers from a local surveying our local science firm, Delta Geomarine, Deep Fried Graphics played a role, and also very important funding support. The Foundation for Louisiana provided some much needed and very welcome support, and I want to just also acknowledge Jessica Kinnison and Rachel Jackson from the Foundation for Louisiana for coming today and for supporting this work. And earlier work that I'll be talking about today was sponsored by the Rockefeller Family Foundation, which I guess actually ran through BRAF as we were discussing, so thanks to BRAF for that. So why should we understand air pollution, right? And why should we understand the emissions of air pollution and greenhouse gases? Why is this important, right? Air pollution is important because it's a health hazard, right? It can lead to problems like eye irritation, as well as more, eye irritation, breathing irritations, as well as more serious diseases like cancer. Greenhouse gases cause climate change. Climate change is rewiring the planet. And it has all sorts of implications, certainly for our flood risk here in New Orleans, but also for things like insurance spikes, health outcomes, changes in insurance markets, and even global strategic realignments. People are going to now likely ship boats, shipping boats through the North Pole as the Arctic melts, and that's going to change shipping routes, which a lot of people in Louisiana are interested in. Probably change the kind of boats that get built. Which, as Louisiana is a place that builds a lot of boats, is interesting to think about. And Louisiana is a large emitter of both air pollutants and greenhouse gases. So we have a need to really understand this. And so one of the questions we just want to start off with was just, where is all of this? What are the sources of greenhouse gases and air pollutants in the Gulf South? How do these things change over time? What communities are impacted? And how are these places' emissions different in, say, Louisiana versus Mississippi versus Texas? And can data provide a role? Can science and data provide a role in showing us where our air pollution is, where our challenges are, and also what our opportunities for progress are, right? Science is about discovering the world. And a lot of the reason that we want to discover the world is so that we can make better decisions about how we affect it and how it affects us. And so at the end of the day, that is another goal of this science. This came out of this is a report these are some emissions percentages that came out of the Louisiana Climate Action Plan. And I actually met Camille Manning Broom while working on the Climate Action Plan, and that led to my invitation here today. So this shows where greenhouse gases are from. Can I use that as a pointer? Or I can use a pointer. That works. No. Oh, that works as the pointer. There's the pointer button. So on the left, we have emissions in the United States, and on the right in Louisiana, and they're categorized by different parts. So this is commercial. This is the transportation sector. We've got amounts in residential, commercial sector, industrial sector, electric sector. In most of the rest of the country, the biggest source of emissions is cars. And after that, it's electric power. In Louisiana, our biggest source of emissions is industrial. Cars are only about 19%, only about 20%. Short story, we've got a lot of industrial facilities, and I know it doesn't seem this way when you're driving through traffic at 4 or 5 o'clock in the afternoon, but as a state, we don't have that many cars. No, I know that doesn't always seem that way in Baton Rouge at the end of the day, but in general, we don't have that many cars. And let's see, what am I doing to move this forward? Do you mind? let's see, maybe do I point it this way? Oh, I think I got it, okay. Okay, so these are some of the major air pollutants, and just to kind of point out, air pollutants are a little bit different from greenhouse gases. Greenhouse gases warm the planet. Air pollutants are things that are harmful to breathe. They're often somewhat differently, but they can have the same source. So air pollutants include things like ammonia, black carbon, carbon monoxide, mercury, nitrogen oxide. These are often things that make it hard to breathe. Some like this category up here, it's a terrible name. I don't really like the name, this NMVOC, but it's non-methane volatile organic carbons. Things that are like things that sort of are gaseous that come up into the air, like gasoline fumes would be an example. It could be something like formaldehyde. These are often things that come out of like crude oil. They can come out of other things as well, but they're often sort of an industrial byproduct. Particulate matter, which is just kind of soot, sulfur dioxide, which was a cause of acid rain. And I'll talk to you today about nitrogen dioxide, NOx. I'll talk to you today a little bit about the non-volatile organic compounds, a little bit about particulate matter. These things, for the most part, they don't really cause global warming. The things that, there's a little bit of an overlap, I'll tell you about in a second. The things that cause global warming, are, if you don't, let's see, I put up that cursor. The things that cause global warming are carbon dioxide, methane, and nitrous oxide. So carbon dioxide, CO2, it's released when you burn fossil fuels. We release a little bit of carbon dioxide when we breathe the air. But it's often a fuel combustion source. Methane's a greenhouse gas. It's a major component of natural gas. Let's just stay on that. That's okay. And nitrous oxide, I won't talk a ton about that today, but it's often like a byproduct of fertilizer. Carbon dioxide is like the sort of major greenhouse gas. We often say it has a global warming potential of 1, which just means everything's related to CO2. Methane is actually like molecule for molecule. It's like 84 times stronger than CO2, but it doesn't last for that long in the atmosphere. So it's got an atmosphere. So it's got over 100 years. It's 25 times the strength of CO2. There are some differences in these, but they can overlap. So methane and VOCs can combine with nitrogen dioxide to produce ozone, and ozone is both a health hazard and greenhouse gases. And some particulate matter, especially like black carbon and soot, can trap heat because it's dark, and sulfate aerosols can actually cool the planet a little bit. And greenhouse gases and air pollutions can have the same source, so fossil fuel combustion. This is a map of our greenhouse gas emissions. And I started putting this together when I started working on the Climate Action Plan. This is a map of our greenhouse gas emitters in 2010 or 2018. And you can see, and they're color-coded. Red is like over 1 million metric tons a year. And you can see they basically cluster in 2 main areas. One, a corridor along the Mississippi River between about Baton Rouge and New Orleans, and then another one over in Lake Charles. There's some additional smaller emitters like up in the kind of Shreveport, northwest Louisiana general area, and a few other emitters throughout the state. But our biggest emitters are along the Mississippi River and over in Lake Charles. So that's the Mississippi River Industrial Corridor. That's where our biggest industrial facilities are, right? Those are where the oil refineries are, the fertilizer plants are. Those are our biggest industrial facilities are. We can actually now come up with maps of like where these emissions are. So that was just where the facilities are. This is another way of looking at emissions. And these are like some maps of emissions. These are maps of CO2 emissions. And you can again see where our emissions are along the Mississippi River corridor, over in the Lake Charles area. You can see the kind of like the Texas, Houston, Galveston region stands out as an area of emissions. You can also see, for example, the Tampa area stands out as an area of emissions. You can sort of start to get up into the Atlanta area, also stands out as an area of emissions. And so I started off this process using like a database. And it was like a big data compilation that was put out by the European Union. And they basically calculated emissions of air pollutants and greenhouse gases for every place on Earth for grid squares that were about 6.5 miles by 6.5 miles. Which is 0.1 degree by 0.1 degree, but we'll just call it about 6.5 miles by 6.5 miles. And they calculate emissions from all over the world. And then they sort of spread it out based on where people live and where facilities are and where transportation routes are. It's a phenomenal project. And it basically calculates it, just to do a little bit of math. You will be tested on this later on. But it multiplies the activity data by like an emissions factor. And so basically, imagine that you were trying to calculate the emissions from your car. Instead of putting a sensor on the tailpipe of every car in the country, which would probably be a pain in the, well, actually, I don't know, now probably new cars do that. But instead of putting a sensor on the tailpipe of every car in the country, they basically say, well, how many gallons of gas were used and how much CO2 is released per gallon of gas. And actually both of those we know pretty well because we have pretty good data on fuel statistics. You know how much gas you put in your car, and the gas station registers how much gas was sold at that gas station. And we know how many molecules of carbon are in a gallon of gas because we know that, because that's what chemists do. And so you multiply one by the other and you get the total emissions. And you do that for carbon dioxide and every chemical compound every one of the major chemical compounds, and you can get a map of emissions of the whole world. And this is what a map of emissions for the U.S. might look like. And you can see hot spots and cold spots. And so you can see the Houston-Galveston region. You can see the Northeast is a hot spot. You can see in California, like the Los Angeles area is a hot spot. The Bay Area is another hot spot. And I wanted to scale into Louisiana. And so we took these data and then we compiled these data for each county in Louisiana and each parish in Louisiana and each county in Mississippi, and we came up with something that we call the Gulf South Emissions Tool. So GulfSouthEmissions.net is where you can find these data, and we basically summed up all of those little dots for each county and each parish. And you can start to see where our emissions come from. So this is carbon dioxide, right? And you can see our emissions are, again, along the Mississippi River, over in Lake Charles. And then there's some other interesting hotspots in Mississippi. I don't know Mississippi as well, but I think that there's a power plant and some paper mills over in the area near Columbus. So we did it for CO2. We did this for methane. And you can see, again, these hotspots, big hotspots over in southwest Louisiana. We have those, but in addition to Lake Charles, we're seeing these big LNG facilities come in, so that's showing up in the data. Ammonia is interesting. This was 2018. We see more of it over in the North Louisiana and over in central Mississippi. We can see, again, back to our nitrogen dioxide. We can, again, see the Mississippi River corridor, the Lake Charles region, some other spots in Mississippi. Pascagoula also has a refinery right there. I think there's like a Chevron or Exxon refinery in Pascagoula. That shows up in the data. These are our NMVOCs. These are things like formaldehyde or formaldehyde's an example. Ethylene oxide. There's a whole class of compounds. Some of these are the kinds of compounds that give you cancer, right? Some of these formaldehyde, some of these can be carcinogenic compounds, and we see them showing up over here along this Mississippi River industrial corridor between about Baton Rouge and New Orleans and over in Lake Charles. So this is where we see our carcinogenics. Particulate matter, we see a similar pattern. And you can actually we actually did this not just for 1 year, but we actually did this for each year from 1970, because the data goes back to 1970. And I'll just zoom in on Ascension Parish, because I think it shows like a little bit of what's happened in Louisiana with air pollution and greenhouse gases. So this is carbon dioxide, And so this is 1970 down here, and this is like 2021 up here, and you can see CO2 increased. So as there was increasing development, increasing industrialization, increasing people move into Ascension Parish, we saw CO2 emissions increase. We saw sulfur dioxide emissions decrease. So sulfur dioxide has decreased across Ascension Parish, and that is probably due to two big things. One, it's the Clean Air Act in 1990, which started a cap and trade system that helped get sulfur dioxide out of fuels. And also, that was the Paul Temple years in the DEQ, and he was quite an active Secretary of DEQ, and that was the time. And there was a lot of emission reduction in that time. So we see that in sulfur dioxide, that drops. But we don't see any change in the NMVOCs, in these volatile organic compounds. And so the compounds that are likely to give you cancer are high. These are quite high, and like 14,000, 15,000 metric tons a year. They're quite high and not changing a lot. And for people that are concerned about cancers in the area, that's a data point. So that was calculating emissions. This is measuring emissions from space. So there are now several satellites up there that are capable of measuring air pollution. They basically measure the spectral signal of light, and then they look at the spectrum of light coming off of Earth that's reflected back off of Earth in certain frequencies where certain air pollutants absorb. And there's one satellite that NASA has, and then there's the European Union has another satellite. The European Union satellite gets more compounds, but it only covers the Earth once a day. It has grid squares that I think are about like 7 kilometers by 7 kilometers. The NASA satellite just went up about 2 years ago. It gets the whole continental US like 8 to 12 times a day. So it's great. And this is just an example of what one satellite image might look like. And so we can see in 2023, you can actually see where our air pollutants are, right, along, again, this Mississippi River corridor, over in the greater sort of Houston region. You can also see, there's other hotspots. Atlanta's a hotspot. Right, and so, but look at how much darker, like, the Mississippi River Industrial Corridor is than Atlanta, right? Kind of an interesting comparison, because they have lots of cars and not a lot of industry, and we have a lot of industry and not a lot of cars. So it makes an interesting comparison. And Houston is a lot of both, right? Houston has a lot of both cars and a lot of industry. So what are our objectives? What can we do? We want to develop maps of greenhouse gases and air pollutants in Louisiana, and then produce reports on the status and trends of these, and really come up with some of the first high-resolution satellite-derived maps of active air pollution in Louisiana. And I know some people in the state are concerned that maybe on-the-ground measurements are, maybe not as accurate as you would like, but the satellite measurements are particularly good because they're measuring 8 to 12 times a day. It's run by NASA, which is pretty darn good, and they don't require as many on the ground measurements. And we're hoping to even get better. We think with the team that I'm working with from Duke and UC Berkeley, we think we can even downscale these measurements to like smaller estimates, like 1 kilometer by 1 kilometer, or roughly a half a mile by a half a mile scale grid. Right now, their grids are a couple miles by a couple miles. I think like 2 miles by 3 miles is the grid square that they're in right now. So that's our goal. These are some of the advantages of using this. Is just what I said. Short story, these things are great. They work really well, and they're very much a game changer. They're very much a game changer in how and what we can understand about our pollution in our state and in our world. And yeah, we're starting off with the tempo data. I'll sort of talk to you mostly about this right here. This is one map of air pollution that we came up with, and this is the average nitrate NO2 concentration, so air pollutant concentration from satellites for from October 2023 to August 2025. And again, you can start to see what's lighting up, right? This Mississippi River Industrial Corridor between about Baton Rouge and maybe a little bit north of New Orleans, and another hot spot over in the Lake Charles area. You can see some other areas that are like a little bit warm, like up in the Shreveport area. So we now have like an average concentration for Louisiana for these 18 months. We can actually average this out and get hourly concentrations. So these are hourly concentrations, and I don't see you can't read the units up here. The top one is an area that we're calling Cancer Alley, and we just define Cancer Alley in here as the area along the Mississippi River, 10 kilometers in either direction from the old river control structure down to Phoenix. We just made sort of an arbitrary definition of it. We just basically drew it on a computer map and said, calculate the emissions that are in this area. And Cancer Alley is this sort of orange one on top, and Greater Louisiana is on bottom. So this is what the average concentration is in every hour of the day, and from morning to night. And so they both kind of have the same daily cycle, but you can see Cancer Alley is higher than the rest of Louisiana. We can also do this not just with Cancer Alley, and we've also done this for a time series. So what's this time? So these are our concentrations up here, and these are times here. This is months. So this is October 2023, and this is August 2025 over here. And each dot is a month. And in addition to having the Greater Louisiana and Cancer Alley, and again, blue, that sort of blue and purple, we've also added in the concentrations in Lafayette and Lake Charles. And actually, as high as Cancer Alley is, Lake Charles is often even a little higher. Calcasieu Parish is our highest emitting parish in the state. That's not to say that other places are small, it's just to say that Calcasieu Parish is big. And you can see that Calcasieu Parish is bigger than Cancer Alley, which is bigger than Lake Charles, which is bigger than Greater Louisiana. I thought it was interesting to compare Lake Charles and Lafayette, because roughly speaking, they're about the same population, right? So roughly the same number of cars, but Lake Charles, a lot of facilities, and Lafayette, not that many big facilities. So it gives you a sense a little bit of what the industrial footprint is relative to the automobile footprint. We're now trying to crunch these data with a machine learning model and an AI model to basically analyze this in better data, and then also use machine learning to start identifying the groups of people and the locations of people that are most affected by air pollution, so people can do a better job of protecting themselves. So, and then of course we want to continue this, and basically our goals of continuing this are not to stop here, but to continue this work, do it with more compounds, do it with more time scales, and do a better job, and try and see if we can get even finer resolution in terms of area, and a better resolution of who's impacted. And then I'll just sort of scale out and say, we've been doing this, and I've been really thankful for the opportunity to do this, but other people have done this as well. There was a paper that just came out last week from a group from Johns Hopkins, and they tried to measure air pollution in a different way. They basically drove a truck that was hooked up to a whole bunch of really fancy pieces of equipment, and they drove it around the state, and they tried to measure cancer risk and concentrations, and they basically found something similar to what we found. And I think that this is actually a really important lesson in science. When you see multiple lines of evidence pointing in the same direction, you start to believe it. And so they showed something similar. And then if we look today, I've shown you a couple of different ways of looking at air pollution and greenhouse gas emissions, and they're all basically showing the same thing, right? So this was the map, again, of our greenhouse gases in Louisiana. That's showing the same thing roughly as the satellite image analysis, which is showing roughly the same as a different satellite image analysis. So when you start having multiple independent lines of evidence show you the same thing, that's really the gold standard. And with that, I will just say thank you. So just in summary, big data, satellite sensing, and machine learning and AI are really a great game changer in terms of our ability to understand greenhouse gases and air pollution emissions in the state of Louisiana. And separate analyses all point to this same conclusion. High emissions along the Mississippi River between about Baton Rouge and New Orleans and over in the Lake Charles region. And I want to, and our obviously continued work can help to further understand this and our sources of air pollution and the people that are impacted. So, and with that, I will just say thank you. Thanks to Rotary for inviting me. Thanks to Camille for inviting me. FFL for supporting this work. And actually for BRAF for playing a role as well. So thank you all. Thank you so much. Yeah. And I'm happy to answer questions. I see there's one right up here.
Have you correlated the data to the types of cancers in those areas at the same level?
Not yet. I would love to. And it's sort of just a question. Yeah, I would love to, and it's certainly something I've talked to some people about. But I'd love to, but we haven't done that yet.
And secondly, when we have a disaster, do you show a difference?
We haven't. We're just getting this going, so we haven't looked at that. That is a great question, General.
Well, congratulations.
Thank you.
Telling the truth, you met all the standards. We've been fighting for years to do mandatory air monitoring on the fence line that impacted communities that live right next to the industrial corridor or Kansas Alley. And that's been a challenge because it's denied in the legislature. We did get a grant for multiple $1 million to do for community air monitoring. It was done. Lean, led by Mayor Leor, had vehicles go through. We had a sense. Then the legislature last year said you cannot share that data with the people. So it was collected. It was paid for by grants from the EPA. So I commend you, but I think we've moved beyond just driving the vehicle around with the satellite data, and I commend you for the work you're doing. And we did have a report come out last year, ma'am, on a relationship to these chemicals to cancer, and the Tulane president fired the professor that put the report out that showed a direct correlation between certain cancers and the chemicals that are in Kansas Alley, because somebody big in the Capitol said, we don't want that report out, get rid of that professor out of Tulane Law Clinic that was put that report out that was peer reviewed. So the data is there, but it's being suppressed. And thank you, sir.
Well, thank you, General. Coming from you, that's quite a compliment. Thank you, General.
Thanks for the brief. I was wondering if your data differentiates, because in my background, I was in the Coast Guard for many years. And the maritime industry, ships in general, deep draft vessels that come into these corridors along the Mississippi River in the port of Lake Charles, they emit a lot of particulate, a lot of these greenhouse gases as well. Does your data differentiate between the two?
Not yet, but it could be possible to do that. Yeah, the shipping industry, it can be quite a polluting industry. I have seen like global data sets of shipping emissions, and I haven't really dug into those as deeply as I would like. But there are some global data sets of shipping emissions. You should be able to start seeing, there may be ways to tease that out. And I think people say globally, like shipping emissions are a couple % of global emissions. And I know it is something that people are interested in, is reducing maritime shipping emissions. You may, if it was particularly like soot laden, you may be able to see that show up. But I will say also the sensors we have, while they're great, they're still giving boxes of a couple miles by a couple miles. And so that may not show up. The one thing that does show up is on the EDGAR emissions. They actually do calculate shipping emissions. So I should, as I remember every detail, the EDGAR emissions which is these calculated emissions, do actually calculate the shipping emissions, and you can see some of those on the map. So there's ways to do it, and I'd love to dig into it more deeply, but there are some ways to do it. Up here.
Thank you so much. This is great but scary information. What's the impact of carbon capture?
You know, we haven't had enough large carbon capture facilities in the state to really give an answer, right? I mean, so right now, we don't have that many facilities in the state to give us an answer, right? CO2 is generally not toxic unless there's some kind of like pipeline leak, like there was, you know, Mississippi, there was a big pipeline leak, I don't know, a couple of years ago, right? And people, I don't know, it was like a couple dozen people went to the hospital. So right now, I would say there's not enough data to suggest. I think that is actually an area where like you need monitoring. Like, does carbon, does it stay underground? Does it leak back into the air? A lot of times the devil's in the details. Are they getting out just the carbon, or are they getting out carbon and some of the other pollutants? And if they take out some of the other pollutants, where do they go? So right now, I think I've got a lot more questions than answers on carbon capture, but I think that there's a really important question to keep asking.
We'll ask the final question.
What?
That's the final question.
Oh, that's the final question?
Right. Can you explain at what elevation are the measurements being calculated? Like, is it ground level? Is it 20?
Yeah, great, actually, great. So great question. Yeah, it's the troposphere, so it's ground level to about 30,000 feet. And so basically it's a satellite and it's just looking down. And actually that is actually another technical detail that we're working out. We're trying to correlate some of the satellite images to on-the-ground sensors to better get that answer. So it is just looking straight down.
So it's like an average of that total length?
Yeah, it's technically an inventory, but yes, it's like an average of that whole length. Now, it's probably, most of the emissions are in the bottom, 1,000 feet. The Gulf South is easy because it's pretty flat, so we don't have to worry about topography as much, but it's an important sort of technical issue to look at. I think that's the end of our questions,
Yes.
but I will be sticking around afterwards for a few minutes, so please, if you've got more questions, come up and ask them.